Safe systems programming languages are an ever-evolving aspect of development. Here to talk more about the future of safe systems programming languages and the effort behind it is Ryan Levick, Principal Cloud Advocate here at Microsoft. How's it going, Ryan?
I'm doing pretty well, Dean. Thanks.
Awesome. It's great to have you on board. And I know that you do a bunch of work with the Microsoft Security Response Center. Could you maybe tell us first what they do?
Yeah, sure. So the Microsoft Security Response Center, or MSRC, is basically in charge of security across all of Microsoft. And so that includes Azure and Windows and Office. And they try to make Microsoft and Microsoft software as secure as possible. And that includes things like trying to find different bugs, working with product teams to fix those bugs, and also working with the industry as a whole to make software as a whole safer.
Nice. And I know there's been some pretty interesting statistics about kind of vulnerabilities there over time, right?
Yeah. In fact, it turns out that we're writing more software now than we basically ever have in the history of the world. And that software is, by and large, getting safer. It's getting better, but we're writing so much more than we have before that getting a little bit safer, a little bit better isn't enough. And it turns out that over time, the number of bugs that we introduce into software, and this isn't just the Microsoft thing, this is the software industry as a whole, is increasing. And one particularly interesting part about that, we found at Microsoft that 70% of our bugs, of our very serious mission critical bugs that happen in our software, deal with memory safety, so the incorrect use of memory. And that can include things that you might have learned in college when you were learning about programming, like double free, use after free, kind of the bugs that you're familiar with if you've programmed in C or C++ before.
Nice. And the effort that we're doing here at Microsoft that you've been a part of is called this Safe Systems Programming Language effort. Could you tell us a little bit more about what that is?
Yeah, so for a long time, the MSRC has been looking at this rising number of bugs in our software and doing a lot to combat that. And about a year and a half ago, they took a step back, kind of looked at the whole field of things and decided, okay, what can we change to do an even better job of combating this issue? And out of that came the Safe Systems Programming Languages effort, which is an effort to make our systems programming languages more safe. And really, it's a three-pronged attack. The first one is to make C and C++ safer. We write a lot of software in C++ and even some software in C still. And it's important that we try to make these bugs that we're introducing in C++ harder to do so that we just end up with less of them. The unfortunate part of that is that we've, in some ways, reached a wall. We can't really do much more than we already have. And it's becoming harder and harder and more costly to address these issues over time. So we're going to continue to do that, absolutely, but it's definitely not the end game. The next thing is a research project called Project Verona, and this is doing research into safe systems programming. We do a lot of research here at Microsoft and Microsoft Research, and this is just one project to kind of explore the space and come up with a new programming language that can be used for systems level programming, but is completely memory safe. Now, what will come of Project Verona in the future, we're not really sure. Like all good research, it's research, and we don't want to constrain it down to being production ready today because that's not the point. And so we need to look out to industry to see what the best alternative to C++ and C for systems programming is today in the industry. And it turns out that language is a language called Rust. So that's the language that we're looking into and looking how we can adopt this language to make our system software at Microsoft more safe and more reliable.
Nice. And I definitely forgot to kind of mention this up top, but Ryan, I like to call you Mr. Rust, right? You are all things Rust. So we've got the right person here to tell us about it. So Rust seems to be the best alternative we have right now as a systems programming language. Can you tell us a little bit more about why Rust is the ideal choice there?
Yeah, sure. So for those who maybe have not heard of Rust before, it was originally developed by Mozilla for the Firefox web browser. And so it's used for these sort of low-level tasks And it's really great for systems level programming because it doesn't have a garbage collector, just like C++. It can run at speeds as fast or sometimes even faster than C++. And the best part about it all is that it's completely memory safe. So all of those bugs that you know about from C and C++ programming, like use after free, double free, all of these things and more, things that you might not even think of when you're talking about memory safety, they're completely impossible to do in Rust. And so, Dean, you were saying, I'm Mr. Rust. I definitely am a fan of the language for sure. And the great part is that these kind of really great core properties of the language means that other people here at Microsoft and across the industry are becoming fans too, because when you program in Rust, you don't have to worry about a whole host of issues that you do have to worry about when you're using some of these other languages.
Right. And I guess that probably means that those 70% of vulnerabilities that we see with memory safety issues, we can potentially or definitely, I guess, eliminate with Rust, right? Because it doesn't suffer those same characteristics or downfalls, I guess.
Yeah, absolutely. So Rust by default is completely memory safe. So those 70% of issues you just wouldn't have. And I mean, wouldn't it be great if we could just say, hey, 70% of the worst type of vulnerabilities that we have in our software, wouldn't it be awesome if it just all went away if we started using this language? And that, in effect, is the promise of Rust. Now, I should say, and I should mention that Rust does have an unsafe keyword that allows you to do some scary bits, because it turns out it's really hard to prove that everything that you do in your software is 100% memory safe. And we write some software that really does some some really strange things and needs to do some strange things. Think about, for instance, writing some kind of driver for hardware. And that driver might say, hey, if you want to turn this microphone on, then write to this memory address. And Rust, of course, has no idea that writing to that random memory address is an okay and correct thing to do. And so for things like that, where it can't prove that you're doing the right thing, you have this unsafe keyword that allows you to kind of go in and do what you need to do. But the fortunate thing is we've done a lot of studying on how often you need to use this unsafe keyword. And it turns out that it's usually, for most production software, way less than 1% of lines of code are needed to be unsafe. And so for our security engineers here at Microsoft, it's a really great thing to say, hey, less than 1% of the code we need to go through and do the old security checks that we're all used to. But this 99.9% of code that exists outside of that, you don't have to look at it at all, because we can prove for a fact that it is completely memory safe.
That's awesome. I love that. Yeah, I guess it's good to have that flexibility in the language to do that. As a company like Microsoft, we're not just writing "Hello World," right? So that's really interesting. The one thing I'm thinking is people might be watching this and thinking like languages like C# or Go are memory safe languages. Why the Rust angle on this?
Yeah, absolutely. C#, Go, there are a lot of fantastic memory safe languages out there. Others come to mind as well, Swift, Kotlin. These are wonderful languages. The problem with them is that they are not necessarily appropriate for systems programming. And that's what we're talking about here today, systems programming. And it's kind of, it's hard to define what systems programming means. But I think for this purpose, the way you should think about it is anything where a garbage collector is not a viable thing to have. So when we're programming, let's say, Windows or the core infrastructure of Azure or the new Microsoft Edge or something like that, you don't want to have a garbage collector coming in and randomly introducing pauses and things like that. You need to get as close to the machine as possible. And of course, we could write assembly code that might get us a little bit closer. But as an industry, what we do when we need to get close to the machine is we typically write C and C++. Those are the languages that get us as close as possible. And Rust is now an alternative to that. With Rust, you can sort of have the same low-level performance that you would need from C++, but in a completely memory-safe way. So I think when you're thinking about this language and you're thinking about, should I learn Rust, should I not? Well, first of all, why not? Learning languages is great. It's always fun to go out and learn a language, but if you're thinking about, will Rust really add something to my arsenal as a programmer, I think the best thing to do is say, how often do I use or do I have a need for languages without a garbage collector? How often am I writing software where garbage collection is just not a viable thing to have? And if the answer to that is never, then that's fine. Keep on using C#, keep on using Go. These are great languages. But if you answer, hey, yeah, every once in a while I want to write something where I can't have a garbage collector anymore, it's just not viable for me, then the best thing to do is to go out there and learn some Rust. I really encourage you to do so.
Nice. You've got me excited to go ahead and learn a little bit of Rust now as well. And I guess this Safe Systems programming language effort. So what does this mean? Is a Microsoft now leveraging Rust? Are we using Rust within Microsoft today?
Yeah, so I mean, it's still very early days, and this is all kind of the beginning of our process. But we've done a lot of research into the language to know that Rust is a language we want to invest in, and so there are core infrastructure pieces in Azure and in Windows that are being rewritten in Rust to kind of test out to see how it goes. We know theoretically that we can get rid of 70% of these issues if we rewrite in Rust. So what does that look like in practice? And we actually have a couple of components already that have been shipped out and are running right now in Rust. And so what we're going to do is go back and take a look and make sure that we confirm what we believe will be the case, that we will get rid of a large swath of our hardcore security issues by using this language. And if everything goes well and all signs are pointing that they are going well, we're going to continue to invest more.
I love that. That's great. I can't wait to see how that kind of evolves and the wider adoption of Rust within Microsoft. And I guess it's probably worth noting, and you touched on this earlier as well, is that this doesn't just apply to Microsoft, right? Anybody who's writing systems, right?
Yeah, absolutely. Rust is a completely open source language, so it's available for anybody to use. You don't need to pay a license or anything like that. Just go to GitHub, github.com/rustslang/Rust, and go check it out there. And so anybody can use it, and it turns out that a lot of companies are using it. So just to throw some names around, Amazon has confirmed that they're using Rust. Google is using it. Facebook is using it in a big way. So you have these kind of large players, as well as smaller but important players in the software industry like Dropbox, Discord. All have moved some of their systems over to Rust, exactly in the use cases that we've talked about before, where a garbage collector was just not viable, and they're singing Rust's praises now.
Love that. And if somebody's watching this now, like me, and they now want to go ahead and learn Rust, you mentioned there was the GitHub repository, but also you've been telling me about this book that I should go and read about Rust, right?
Yeah, absolutely. There's it's sort of known as the book in quotes in the Rust community, and you can just search for it online. The Rust Programming Language book by Steve Klapnick and Carol Nichols is a great, fantastic free resource for you to learn Rust. And Rust, I would definitely encourage everybody to give that book a read before kind of just diving in. Rust definitely is a language that requires you to kind of get a little bit of knowledge about it before you start hacking with it. But if you read that book, that does a really fantastic job of taking you through and teaching you about Rust and helping you learn the ins and outs of the language. Give that a try, and it works. Obviously it works great on Windows, but also on Linux and Mac, and for whatever system that you want to develop for. And so give it a try. I hope you have a lot of fun with it.
Awesome. I'll definitely be checking that out. So unfortunately, that's all we've got time for, Ryan. Thank you so much for joining us. Next up, we have Amy, who is standing by with a quick Hack for Good challenge. But first, a quick break. Stay tuned.